Hello, my name is Antonis, and this is a project about probabilistic nomograms. Now, what are probabilistic nomograms? In order to understand that, we first need to look at physical nomograms, and I will have a little guide. I will now be showcasing the physical nomogram, so let's have a look together. Very nice. So, this is the fuel nomogram. As I said, it maps kilometers, liters and kilometers per liter, essentially a division equation. How do we use it? Say, my car has 50 liters. I will mark this point here. Well, normally it is operated with a ruler, okay? But my ruler is not big enough, so I'm using a piece of paper. So, say my liters are around 50, and I want to travel to 700 kilometers. I draw a line between these two, and it tells me here I will need an efficiency of 14 kilometers per liter. They are essentially a calculator in graphical form, and you can choose any two variables as inputs or outputs. For example, look, I will say now I want to travel 400 kilometers, and I have an efficiency of, say, I don't know, 10. How many liters do I need in the tank as minimum? I will again use my ruler, connect these two, and I will need 40 liters in the tank. And you can do the same thing with, inputting liters, efficiency, and having the other one be the output, the distance. It can map anything. So, now that we have a bit of a view of how nomograms work, here is again the same nomogram. What are they? They are a graphical calculator, they are ruler operated, and these days they are not really used for calculations per se, they are more used for visualization purposes. And as mentioned, the problem that we have is that you need to give it a specific input and get a specific output. This is very unrealistic because in many use cases we don't know the exact input. We know roughly what sort of range we're looking at. So we're looking to build probabilistic nomograms that follow arrays of inputs and outputs. Side by side here we see the regular nomogram and the potential probabilistic version. As you see, we go from having say just one input, well, okay, I didn't visualize the isopleth, but you can imagine, into a range of inputs for each variable and subsequently a range of outputs. This is just a conceptual overview. So some quick trivia on nomograms. They were engineered in 1880s by a French mathematician. At the time, were quite a big breakthrough. They were mainly used by engineers to do, because we didn't have calculators back then. But nowadays, they're used mostly as a visualization tool in the fields of medicine, specifically a lot in oncology, the medicine of the field of cancer, and also a little bit in finance. So in the diagram that you see here, we have an oncology diagram where patients or nurses can enter some of the vitals and get the probability of the patient surviving a few more days. A bit macabre, but it is a visualization tool in the end. Regarding requirements, I chose the nursing sort of context to materialize our ideal user. So this was split into 3 sub-users. It'll be the supplier or vendor user. This user will provide the already generated nomogram following a specific equation. Secondly, we will have the nurse user. That user will be operating the nomogram. They will be sliding values up and down, but they will be the ones interacting with it. And thirdly, we would have the viewer or patient user. That user's job is to merely just conceptually understand what is being shown to them. A lot of requirements were made, and they were ranked in a Moscow table. Here I'm only showing the must-haves, which the MVP does and should have, implemented, but there is a full table available on the dissertation. So, in order to build this sort of interactive nomogram on the front end, we needed to have some representation of the axis. As you can see here, we would need to know, each axis, what values does it carry, what locations are these values on, and these values and locations must be mapped together. They are in an ordered structure. And a dictionary was built out of that for the front end. So what is the order? The order is, using the full PyWeb view front end, we choose one of the pre-selected nomograms. We have fuel, multiplication, and addition, I believe. We choose one of those options. The nomogram generation takes place. The backend has been intercepted to collect the values and the coordinates. So we grab these during the execution. And together with the picture generated by Pynomo, and then we collect the data structure, we collect the picture here, and we give them to the front end. And the front end builds a few interactive components on top of the data structures I just mentioned, and that is the interactive nomogram. So now finally it would be a good time to make a very quick demo on what this looks like, and I will upload this right after. Hello, so let's have a look on how to run the software. I have activated my virtual environment. I am under nomogram generation front end, and I want to run this main.py here, python main.py. So this will spin up the front end for generation. I can choose any of these three presets or make my own. I will choose the fuel one. This will run the function over here, fuel.py, and actually generate our nomogram. It will catch the values during interception. Good, so 10-20 seconds or something like that. We have now augmented the nomogram. It is now fully interactive. Let's have a look. I can drag the circles around very nicely, all three of them. And the two most recently used circles, they act as the input. These are the ones I can move. And the other one is extrapolated as the output. You're not dragging the middle one here, for example. And this is dynamic, obviously. Now, you see some uncertainty circles and some uncertainty lines generated. These are sampled randomly from the circles. If I increase the spread, I increase the how spread the noise is. See, I can lower it or increase it for, more or less noise. I can also just turn it off if I want to keep things neater. Now, if this fails for whatever reason, you can also just try it over here on the GitHub link. I'm hosting a live version. So yeah. Now, regarding evaluation, the core idea was to evaluate the probabilistic interactive nomogram, which is the software version, against the leaflet or the physical version. And we tried to compare how viewers, how they found each version, try to give them similar questions to get some sort of baseline. The evaluation relied on a Google form. Two different forms were given to users, one with the physical version first and some questions with a digital one after, and another form B that was given in the reverse order, so first digital and then physical. In the actual survey, we had users do some simple tasks. So if you see an example over here, they were given a very simple computation with exact inputs and an exact output expected. And after each of simple task, they would be rating how confident they were in the result. And you can see the distribution plotted on the graph, where we had kind of mixed results regarding that. Slightly higher on average confidence for the probabilistic version, but somewhat noisy results. Now, the evaluation also contains some uncertain tasks, which were kind of the bread and butter of our assessments. So here's a problem statement. Your tank has a maximum capacity of 100 liters of fuel and you get it filled to around 2/3. Your fuel efficiency was quoted around 9 kilometers per liter, but your technician said the efficiency may be up quite a few points. So we're trying to introduce an uncertain context to the question. Your friend Antonis wants to go on a night trip 750 kilometers away and there will be no gas stations in the end. How confident would you feel going there? Basically, having users do some sort of computation using the nomogram, and there is a certain level of uncertainty. What will you put 9? Will you put 8? Will you put 10 for the efficiency? So we have users do that, and we ask them to rate how confident they would be to reach, say, 10,000 kilometers or 900 kilometers or 800 kilometers, and we rank these. We collect and rank these distances. The results are shown here. So on average, we have a lower certainty using the probabilistic nomogram. So users were overall less confident choosing specific answers regarding this, which makes sense, kind of. That was kind of the point, to make users feel that there is some uncertainty, there is something in the context beyond the immediate values. So not only do we see lower averages across the board, we also see a higher spread, which is interesting. We see that not only were they unconfident, they were also disagreeing with each other. So we added a lot of noise to the results, as was, hoped for. Additionally, we also wanted to plot the time taken for the probabilistic nomogram versus the physical nomogram, because the tasks were pretty much identical with different numbers. Interestingly enough, there was no correlation between the time taken of each. Could be due to low sample size. As you saw earlier, we only had 9 participants of fairly homogeneous backgrounds, so maybe because of that. So, to summarize, development was a success. The evaluation was it was generally enjoyed by users. We did show a lower confidence scores in the uncertain scenarios. Nevertheless, the results were quite noisy. It would be very nice to have more users than 9 evaluators, but this was due to budget and time budget constraints. Regarding next steps, obviously, having more access than supporting more than 3 axes or non-linear axes, something like curved ones, would be great. And we could also simplify the building process, because installing Pinomo requires a package which is very cumbersome to install. So at the moment, a lot of the things are manual. So this could maybe streamlined by a containerized solution in the future. Thank you.